just the introduction here. So my name is Mike. I'm a data scientist in our global technology practice team. So I work with all the newest technology from SAS, helping all our customers getting started, but also some kind of pre-sales engagement with our customers. So I'm doing various kinds of demos and presentations, kind of like this, and just expanding the knowledge about SAS and especially SAS Viya, our newest platform. So I've been with SAS for the past, I think, 5 years now. The first 4 years I worked as a consultant in the Nordics in an analytics department, where I implemented all kinds of machine learning projects with our customers. So I've been working with text analytics and just conventional machine learning models. Kind of did most of it. The past few years I worked in banking, and I worked closely with our global financial crime team to implement financial crime models for some of the big banks here in the Nordics. So today I will show you, first I have, I think, 10 slides, something like that, just to introduce the model ops using SAS Viya. And then I have some hands-on stuff. So I think most of the 2 hours here will be hands-on. So this is a picture. So if you saw the presentation from my colleague Kasper Pedersen on Monday, he had a keynote presentation. So this is one of the funny slides from his presentation. And I think we've all seen it. There are so many vendors in machine learning and AI and data. The landscape just keeps expanding. There's just more and more complexity, more and more demands from different departments within companies, and they are not always aligned. It's difficult to make a governance in model. And basically, the state of the art, it changes by the week. There's always something new to learn, and this can be overwhelming for a lot of people. And this also makes it very difficult to actually get things into production. So some of the big analytics firms here, for example, Gartner says that 60% of models are never being operationalized. So imagine that I think we've all tried it, that we sit there and spend weeks and weeks creating models, and then finally we kind of deliver it to the business. We say, hey, look, this is our best model. This is doing exactly what you wanted it to do. And then suddenly it's just like, well, no, thank you. So it's not necessarily a tech problem. That's the reason why we're not deploying models. There can be all kinds of business issues or business problems involved in that. McKinsey says that data analytics initiatives fails, and Bain says that 70% of companies see that the AI strategy is critical for the business, but only 10% of the companies are actually doing it. And I think that's also my experience as a consultant, that when you speak with a customer, at least in the sales process, that's not the thing that they haven't done before. But then when you actually open up the system, you see that the data quality is not really good. It's difficult to find data in the systems, and actually, extracting all the data to a single platform where we can start modeling is a challenge. So I think this is a traditional model lifecycle type timeline. So what we want to do as a data scientist, at least what I want to do, what I aspire to is have my skill set in a high demand in the business. So how do I do that? Well, I generate value through analytics. So the first one, okay, it simply just skips to the next slide. Perfect. The first one here, the red one is basically just a cost. A data scientist sitting there and preparing data and building models. Then maybe in the IT department takes over, recode the model. Maybe you have coded in Python, now it needs to be in C++, otherwise you can't integrate it with the system. And then that's a bit annoying. And then we manually deploy it. And then once it's deployed, we see that the value start being positive here. So now we can actually use it to score new observations. Let's say that we have a credit scoring model. We can start scoring new loan applications. We can filter off the bad applicants right away. Okay, just click back again. But we probably lack some governance or model monitoring or some retraining. There can be all kinds of things why we're not getting the full value out of our models. So what we are aiming to, or what I think we should do, what SAS is aiming to do is limit that time where we spend on data preparation and model creation. So can we do that automatically? Or at least can we speed it up somehow? Can we make collaboration easier across teams? Can we make data engineers, data scientists, and IT people working together? And then streamline the model deployment. Can we do it all from one platform? And the decisioning, can we put this business decision on top of the model output? Can we monitor the model, govern the model? Basically make sure that the model keeps having the same high performance as when we deployed it. And for that, we need to retrain it sometimes. We need to rebuild it. And maybe we kind of need to rethink the whole process from time to time. So that's kind of what we're working on. That's the model and the whole thinking we have at SAS. We want our analytical platform to be able to do just that. So to that, we have an end-to-end model lifecycle. And I think a lot of companies have something like this, but we have 3 steps. We have, well, first of all, we have a question coming in, and we want a decision coming out of our analytics process. So the first step is the data ops. So we need to gather all our data. We need to assess the data quality. We need to make sure that it has up to standard. We need it to be we need to be able to actually use the data for our models. And the next step is the artificial intelligence step. I think that's the buzzword today. We need to do some kind of analytics on it. So is it machine learning, deep learning, or just some simple statistics? We kind of want to work with the data to get some insight. And once we have that, we want to deploy the model, and that's the whole model up step. The model ups is basically we deploy the model, we monitor it, we have some kind of governance around it. So once the classification rate drops 10%, or the area under curve drops, or all kinds of things can happen, then we probably have a standard or a procedure for how to retrain the model, or what should happen next. So the challenge is basically to compress the time needed to deliver decisions. So basically that red box before, the initial cost, can reduce that time and basically just get something in deployment as soon as possible. We probably want to do that with as few manual steps as possible. So we want our platform to actually be able to automate some of these things, or at least do it with very few clicks. So if we dive in a little bit, so we have some model capabilities. I think you're all data scientists, so you can probably all build a model. We want to automate some of the tasks. So for example, we want feature engineering and model tuning to be automated. So I think there's a lot of vendors who can do that, SAS included. We have some of the state-of-the-art tuning for models, and I think we're also really fast at it. That's also a consideration these days working in the cloud. We want the different data teams to collaborate. So the data ops and the data scientists and the model ops teams should be working and speaking the same language across the platform. And then once you integrate it, so something new with SAS, if you worked with SAS before, SAS 9 especially, you would know that it's not a very open platform, at least not what you would consider open source or anything like that. Viya is still not open source, but we integrate with all the open source languages like Python and R and Lua. So you can actually code Python and R directly in SAS on the platform. You can also ingest your Python model or your R model, and I'm going to show you all of these steps today, and then we can manage it. We can deploy it and make an endpoint API to actually use the model for scoring new data sets. And that's basically what we're going to do here in the model ops. So we can validate, we can deploy, we can govern, and we can embed. So the whole platform is open through REST APIs. So you don't even need to be able to code SAS. So one thing is we can use drag and drop, or we can use an open source language to communicate with the platform and actually use the full capabilities of SAS Viya. I'm going to show you how we deploy a model. We're going to deploy a Python model, and we're also going to deploy a SAS model. And then I'm going to show you how we can set up a governance structure. So imagine you have different data science teams in different departments. Let's say you're a bank, for example. You have a credit line, you have an AML line, you have customer segmentation for marketing, all these different models, and they're being handled in different ways. That's kind of the usual story when I go out as a consultant, that there's different governance models for each department, if there is a governance model. So this is something that we want to streamline. So having the same process across all the teams. So this is kind of the way we do it in the business. So how can you do this? Well, you can actually use SAS Viya, and I'm going to show you today how you can do it. So we have an open platform. It's collaboration is kind of the theme here. You can see that all the user interfaces are streamlined. It looks the same. You have the same feeling to it, no matter what kind of role you have. We can visualize data. We can create models. We can do data governance. We can do data ops. We can deploy models. Basically, the platform is an end-to-end modeling platform. So the first thing is, how do you get started? And you probably remember Casper talking about the Asia marketplace, Viya and Asia marketplace. So that's where we're going to start today. So this is the link. You can click here and basically putting in a few information and some payment options. Then you can actually get started with SAS Viya after an hour, more or less. And actually, if you want to try it out yourself, there's a link here with a QR code for $200 on Asia. That should get you going for at least a few days using this application. So let's jump into it. I think that was my introduction here. So let me close my slides here, and then I actually want to share a different screen instead. So let's share this one over here, and then click share. Can you still see my PowerPoint presentation over here?
Yes, we see it.
All right, perfect. So I'm opening up my browser, and we're going over here. So this is the SAS Viya Analytics your way on Microsoft Azure Marketplace. So if we click this link here, you will see we are being taken to the Azure Marketplace. Because I'm an internal at SAS, or I'm working with SAS, I have to use it a little bit different. So I'm going to use this one instead. It's the same thing. The only thing is I have a private image I can spin up instead. So basically we click on create after we're logged in, obviously. So the first thing we need to select is our subscription. I have a GTP subscription. That's basically just my company subscription. I have a user group or a resource group. That's this one. I can select which region I want to be in. I'm located in the Copenhagen office in Denmark, in the Nordics. And I think the closest one to me is Sweden Central. I think most people in Europe use the West Europe. That's quite big. And also the bigger it is, the cheaper it usually is. But I just select Sweden. Let's say that we want to create an environment here. Let's call it a data science conference demo. And let's call it 2, because I already have number 1 up and running. So we copy paste this one. And I say it should be the same in my DNS prefix. Okay, we should probably do number 3. I guess I have done number 2 already. So what we're going to do is we're going to use DSC demo 3.swedencentralcloudapp.asia.com when we want to access the system. That's important to remember. I'll also show you afterwards how you can actually find this again. First time we log in, we need to use the Viya admin user. So we need to set some kind of password here. I'm just going to type in something random here. So it needs to be 12 characters long. That's it. We want to generate a new SSH key. So basically, if you want to connect to your system through SSH, you basically need to have this private key. And let's just call it DSC demo number 3, then I can remember it. Then you probably want to set some IP ranges. Otherwise, everyone can basically connect from everywhere to your system if they have the login credentials. So normally I put in my home IP and my office IP, so I can use it both at home and from my work. It's not really something that's changeable afterwards, so that can be a challenge. And then we'll put in a application name here. So DSC demo 3, and then we are putting it in here down as well in the name, just so I can just so I remember what my resource is called. DSC demo 3, just so we're consistent here. And that's basically it. So basically you need your subscription, then you need to enter these information here. You need to review, saying, is this actually correct? It will just verify. And we see my price is $0 because this is like a demo service. So I put in my email, my phone number, and I say yes to the terms and conditions. And basically just create. And once I click create, I will be prompted to download the SSH key. Let's download now. I'm just going to save it over here. And then we see up here something starts spinning. So something is actually running now. So right now there's no results. But in roughly an hour, you will see that this has been installed and it's ready to go. So it will look something like this. So this is an environment I already have up. This is DSC demo 1. So see, these are all the services that will be deployed. So this bottom one, DSC demo 1 without any dashes afterwards, that's actually the Viya installation itself. So if we click on that one, we can click on the output. And then I can see that this is DSC Demo 1, Sweden Central Cloud App Asia.com. That's the web page. I can also see the IP address if I want to SSH connect to the Jump server. I can do that as well. And I can also see what kind of Kubernetes version I'm running, what kind of SAS Viya installation I'm running, 2022.10. That's the newest one, and it's a stable release. So let's take this one and just open a new site here and then paste it in. And then let's see what I get. Okay, so I need to put in Viya admin, and then I need to put in the password for this site. And something else you'll be prompted for is that this is not a secure site first time you log in. You have to add the certificate so it knows it's actually you. There's a safe connection. And this is basically what you're going to be presented with. So you can start with what do you want to do here? You can learn how to import Python models, learn how to create reports, load data. But this is basically it. So let's take this SAS Studio. That's probably a good start to just load in some data to the system. It's just going to take a second here. So basically, we're just waiting for the compute server up in the right corner to load. Once that is done, we are able to actually start using a SAS program, a Python program, a flow, which is a drag and drop tool. If you have used SAS before, that is like SAS Enterprise Guide. So let's just create a SAS program. So now we are basically up and running. Let's just try and make a data test, x equal 5, and then run, just to check that it's actually working. We hit F3, and it should be running, hopefully, fingers crossed. Okay, the output data is created. So the server is up and running. I have another demo server where I've already created some things that we'll be using today. So I will just leave this one. And then I will go back to the one we just had here, because one important thing that you probably want to do when you use cloud is decrease your cost. So when you're not using the environment, you probably want to spin it down or at least limit the cost. So to do that, we need to go into the management group or the manage group here. It's basically where you can administrate all the things that are deployed in this part of installation. So you click on the automation here, and then we can click on runbooks. We can start Viya, and then we can click start, and we can click stop up here. So once I stop it, it takes like half an hour. Then the environment is kind of at a minimum. All the SAS services are down, so it's only the storage cost you're paying for. So let's just click OK to this, and it takes like roughly half an hour. So now we will see it's actually queued up. It's spinning in the Azure. So that's pretty neat. If you for some reason don't want to use your SAS installation any longer, you go to your managed applications. You find your demo environment, and then you simply just delete it. So you just delete it here, and then all billing costs will stop. It's basically just removed from your cloud. So I think that was kind of my introduction to how to get started with SAS Viya. Are there any questions? See if I can bring up a text box over here. Okay, maybe I cannot. Why is that? Cancel. Okay. All right. Let's just go on then. All right. So the next step is that I will show you I have a GitLab repository. Can you still see my screen here?
Yes, we see everything. Don't worry.
Perfect. All right. So in here, I have created, I have some data sources. If you are familiar with the HMEQ dataset, I think most data scientists have probably seen that. The same with the IRIS dataset. It's a it's consumer risk department of a bank that wants to automate the decision process of giving loans. So basically there's, I think 6,000 observations with some different data in it, some different variables. So what we're interested in is the bad. So did the client, the loaner, did they default or did they actually pay back the full loan? And that's pretty interesting if you want to do credit scoring or you want to do a probability of default models for banking. So that's going to be kind of our story today. So can we build an application for a bank that can automate the loan process or the decision-making process in the loan process at least? So we have the bad. We have what kind of loan size are they asking for? How much is left on their mortgage? What's the value of the current property? Why are they seeking a loan? What job do they have? How many years have they been in the job? Have there been any derogatory reports? Have there been any delinquent credit lines? Basically, they haven't paid their credit. What is the oldest trade line they've been using? How many recent credit lines do they have? And number of credit lines in total? And what is the debt to income ratio? And this last one is quite interesting, I think. So if we go on to this environment I have up and running here, I will just log in. I will log in as an administrator. So here at the top, everything in SAS Viya is basically controlled through the URL. So I'm going to SAS Studio, which is the coding interface. And you can also just click in the left side and you have all the different products here. So in the analytical lifecycle, we have manage data, prepare data. We can explore it. It's like a visual analytics. We can build models, we can manage models, we can build decisions, and we can do SAS coding. So let's start with some SAS coding just to use our Git repository. So if you're not familiar with Git, or in this case GitLab, it's a version controlled system. So I've basically just hooked it up down here. So you see this is the exact same folder structure as you saw in my GitLab over here. So we have the data work, environment settings, Python, R model, SAS model, etc. And it's the same thing I have over here. So whenever I make a change here, I can just push it back to my GitLab. So I can take it with me wherever I go. So we first see that I have the data sets over here. So we want to read one of these data sets in. So for that, I have a script here, initial data load. So the first thing we need to do is create a CAS session. And CAS is what we call Cloud Analytics Service at SAS. So normally, if you code on SAS, you use the compute server that you just run a SAS code. In the CAS environment, you use CAS actions, and they are basically parallelized and optimized SAS code that runs faster. So the first thing is we initiate one of those sessions. So we just hit F3, and then we see what's happening here. So we connect to we connect this to a session called My Session. We have a CAS user library. So if we go down to the libraries over to the left here, we see there's now a little different logo over here. That's the CAS lib. So we have all the 5 data sets in here that we also have in our GitLab. So we're going to use the HMEQ data set for modeling, and then use the 1, 2, 3, 4 to monitor or simulate that we're monitoring our model once it's in production. So whenever the model starts deteriorating and there's a shift in variables or something, we can actually see that. So I will not be running these 2 pieces of code here, but that's basically just to ingest the CSV files into the system. So let's for the simplicity of the story, think about it like this: that the data ops team have made these data sets available in SAS. They have done data quality, they have data lineage, they have all the things we need to create proper models that are ready for model ops. So that's it. Then we can actually also in here, if we want to do this through Python instead, we could use Python code. So this is basically just a Python instance where you can put in Python code. I think I will skip that part and just go directly to the visualization instead, and then start exploring this data. So up in the left corner, I can go to Explore and Visualize. We click that one, and we will see a new user interface. And this time it's Visual Analytics. And it's just going to load, and we're going to say, no, we don't want the old report. We want to start with a new one. So it's loading up, and we click on Start with Data. So here we have all kinds of data sources. So let's go to the data source, to CAS, and then we want the CAS user. That's the one we just uploaded the data to. And we see that we have the HMEQ dataset. And we can just check that it's being loaded correct. So we have these 13 observations or 13 variable names, and we have roughly 6,000 rows. So we are good to go. Let's click OK here. And if you are familiar with visual analytics, either on the SAS 9 version or in SAS Viya 3.5 or in this newest version of SAS Viya, then it's going to be the same. So this is basically just a drag and drop interface. So for example, something I tend to do when I start with new data is loading the target variable. So what is it I'm kind of trying to model here? We see we have 4,700 people that haven't defaulted. That's the zeros. And we have over here roughly 1,200 that actually did default. That's maybe not as telling. So let's see if we can put a percentage on it. So it's like an 80-20% split. So 20% of the data set is actually defaulted or consumers or loaners that didn't pay back their loans in time. And the other 80% are someone that basically want to give a loan. So we need to find if there's any correlations in the data sets. So maybe the next one we can put in is the loan. That was how much money did they actually ask to loan. And we see there is someone who asks for $3,000, and I think the maximum is like $90,000. So it's quite a span. Maybe we can see if there's a correlation between these. So if we take bad and we take loan, just drag it in simultaneously. We can see the non-loan giver, the not bad over here in the left, and to the right we have the bad ones. We can see that if there seems to be some kind of a tendency here that if you have a very high loan request, then you tend to actually pay back your loan. Whereas at the bottom part here, it's kind of the same. Probably difficult to say anything about it at this stage. And then I just need to see my notes here, what I actually were supposed to do here. So basically that was the first one. The next one is we can probably create a heat map. So we just mark them all, put them in to see, is there actually any, the following items want to decline. Oh, that's fine. Are there any correlations here? So the darker the blue color is, the better it is for predicting our bad. So bad is the first column here. So we can see that's something with the credit line age, the debt to income, the delinquent lines, and the deteriorated reports is probably some significant variables or something we will experience to be significant. And I can't remember what this NINC was, but it also seems to be weak relations. There's no strong relations per se. Okay. What we can do in here actually, which I think is pretty neat to show sometimes, is that we can actually create a model, just an initial model to check, is there actually any correlation in the data? So this is called visual statistics. So let's just for the fun of it, build a decision tree. So we put in a decision tree here. We say, what is our response variable or a target variable? We say that's going to be bad. And our predictor, let's just make it simple. So let's take value and let's take loan and let's take how long you were in your current job. So now we actually have the first model. So we can see that there's an average square error of 0.1, seems to be okay. Value seems to be the most important correlated variable here. Loan is the next one, and how long you've been in your current job. The assessment is I guess it's a model. It's not a very good one, but a neat feature in this Viya is that it's, even if you're not a data scientist, you will get these small helpers that kind of explain what's going on. So this one, you basically just click the information or the eye icon, and then it kind of tells you what is going on in that specific area. And we're also going to use this when we actually start creating a real model to So here we say that the data is sorted in descending order by the predicted response bad. The data is divided into 20 quantiles, blah, blah, blah. So basically it just explains how you create that specific graph. Yeah, I think that was the visualization part. So let's try and go on to something a little bit more sophisticated. So we go up to the left corner. I usually tend to call these 3 lines. I call it a burger menu. So we go to the build model through the burger menu, and it's loading up. We don't want to assume a project. We basically just want to start a new one. I've already made one DSC demo 1 just to test that everything is working. So let's create a new project, and very conveniently, let's call it DSC demo 2. And then we can create what kind of project we want. So we can do machine learning and data mining. That's what we're going to do today. But we also have the options to do forecasting, basically time series modeling, and working with text analytics. So let's do that. Data mining and machine learning. We start with a blank template. I think we have some stored here. Basically, if you want to do auto modeling, you can just have a template with 100 models, and it just runs through all 100 models. So the data set. Again, the data source, cache user. We select the HMEQ dataset. We see it's the same one. We click OK. And we can put a description. This notebook will be used to predict if a customer will default or not. All right. And then we click on advanced here. So we want to do a partitioning. So we can split it stratified. It's basically depending on the target variable. In this instance, we want a 70, 30, and 0 split. We don't want a test data set in this case. We could also do some kind of up-based sampling. In this case, I think an 80-20 split in the events is okay. But we could say that we want to sample more of the events than non-events. So we just click save here, and we click save again, and then it will create a project. So the first screen we'll see is a screen with all the data. We need to verify that the data has been classified correct. So it says here up here that you must assign a variable with the role of target in order to run a pipeline. A pipeline is basically our way of creating models. So we start with creating the target. So we mark bad. What was our target? Did you default? Did you not default? We change the role. We change it to target. We know it's a binary, and we have to select the target. The system will do it by best guess. So it selected 1 for us. So we just click cancel. And then we have 2 text variables. We had reason and we have job that was marked as text, and they are also loaded in as characters. So that seems to be correct. All the other variables are numeric. That's good. And then there's different levels. It's binary, interval, nominal. So nominal is like it's a category. So that's fine. Let's just leave it as it is right now. But we could actually change it if you want. We can also see how many is missing. So some of the variables like the debt to income, and the same with the derogating report is also quite high. So we probably need to do some kind of imputation. So let's go on to the pipeline here. So the first step is the data step. So let's just drag that up a little bit. So what we can do is over to the left here, we can click on nodes, and we have 4 options: data mining, pre-processing. Let's start with that one. So we have different things that we can use. So we just saw that the data set included a lot of variables with missing observations. So let's take the imputation. So imputes missing values for class interval inputs using the specified methods. That sounds something like what we want to do. So we put it down here. And then up comes an options menu. So how do we want to do our imputation? So first of all, we want to reject the original variables. We don't want to use them in our models. We just want to use the imputed. So for our class variables or class inputs, I think we can use none. We are actually, let's use a constant instead. Let's use a constant variable. And for our input variables, let's just use mean. So taking the average and putting that in wherever we have a missing variable. So at the bottom here, we have constant values. And for our character values, let's just put in NA, just like it's missing. So now we can click this. Up at the top, there's a run all pipelines, or we can actually also just click on this one. So let's click run pipeline. Then it will, basically this whole interface is drag and drop. So you don't actually need to code anything. There are some options to do it if you want to add some custom code to one of these pipelines. But basically it's creating all the code for you underneath what's going on here. So the idea is that we will create the data imputation, we will add some models, and we'll select the champion model, basically the model that is having the best predictive power. So let's just wait for this for a moment. While we do that, we can maybe have a look over here to the left. So in the supervised learning, that's all the model options we have. So I think today we will be using the forest model, random forest. And we could probably also use a gradient boosting model. I kind of like these tree-based models. They are kind of fast to run and also quite easy to understand. So let's actually just do that. Let's add a decision tree. So again, I just drag it out, put it to the node I want to attach it to. And here we go. And we immediately get a model comparison. So if I add more than one model, I can compare basically assess the predictive power or the fit statistics across all the models. And it basically does it automatically. So that was the forest. Let's take the gradient boosting as well. And again, we get the options to kind of put in the hyperparameters. Something I like to do is using auto tuning. We can basically give it a grid to create all the models for. Sadly, it often takes quite a bit of time, so I think we will not be doing that today. But something we will do, however, is use the model interpretability. So we have global and we have local things we can do. So variable importance and PD plots, and we also want a ice plot, I think. And we just want to do it with random. That seems to be fine. And we use standard options. For the gradient boosting, we can do the same. So we're just using, basically creating 100 trees. We have a learning rate of 0 to 1, just using the standard options here. So we will do variable importance, PD plots, and local interpretation, ice plots. We'll just click off, click on the model comparison, and then we will click run pipeline. So basically what we're doing now is training a decision tree and also training a gradient boosting. And then we will compare the results of both models. So my best guess is that the gradient boosting model will be the better one in this case, but we'll see. The decision trees have a tendency to overfit a bit to the training data. I think you've probably all experienced that. So this shouldn't take much more than a few seconds. I'm running on a small demo environment. This is just a single node environment. If you're using the environment that I showed earlier, it had 5 nodes, so it can basically parallelize all of these processes to run a lot faster. Basically, train a model on each node instead of doing it in a chain. So right now we see that the pipeline has completed. So let's go to the model comparison. I right-click it, I click on results, and then it just generates a bunch of fit statistics for me. So we have the accuracy, we have the KS statistics, we have the area under curve. It's probably more interesting looking at the assessment. So we can look at, for example, this graph, the lift report. And we probably just want to do it a model at a time. So let's do the gradient boosting first. That seems to be the best one. So if we sample the 10% highest scored observations after we sorted it, we see that we have 5 times more defaulters than we do by just simply randomly picking observations. So that seems to be an okay model for us not having done more or less anything. So that's interesting. Let's try and close that one. And then the same with the receiver routing curve. We can see that the decision tree is kind of bad. The gradient boosting is relatively good. So if we close this one and we go back to the node, we will see that there's this champion logo. So which model is the best? The standard selection criteria here is the KS Uden. So that has selected the champion model because that has the best value. So that's the champion. So if we close this one down, let's have a closer look at that gradient boosting and see if it's actually as good as we think it is. So again, right click it. I go to results. And here you see we have assessment, but we also have one more. That's the model interpretability. But before we actually go on, let's just have a look at what's created here. So we have this scoring code. So if we want to see what is the probability for a new customer coming in, or a new loaner or loan application, what is the probability of that actually defaulting based on our model? We can use this data or this score code here to evaluate that. The same, we also have the DS2 step. We have the input variables, so what kind of variables are used, and the output, what is coming out of the model, quite a bit. We have code to actually retrain the model. So basically all of this can be automated, and I'm going to show that a little bit later. But first, let's go to the model interpretability. So I think this is one of the cool features we have in this instance. So let's say that I have a PD plot. I don't know what a PD plot is. Well, I do, but if you don't do, then you can actually click on the information tab, and you get a text just in plain English. So imagine, I think we've all tried it to communicate with stakeholders from especially the business side. Maybe it could be, in this case, the credit department in the bank. So they are the one in charge of actually approving loans or not. And now you say, hey, I have this model, and this model can actually help you do this more standardized in a faster way. And they're like, yeah, that's fine. How do I interpret the model? What is important? All these things. And you can actually use some of these plain English text to create a report, or at least use it as a foundation for a report. So in this case, we can see this is let's take the loan instead. So the loan size, the distribution, the darker the blue, the more observation we have in that bin. So we can see at the beginning, there's, seems to be a higher prediction for people who are applying for a small loan, and the same with the ones applying for a big loan. So the model is actually picking up those signals in the data, and then there's an average that seems pretty okay. The same with the PD plot. It creates 5 different groups, and then it kind of looks at what is the in this case debt the debt to income amount, and how does our prediction alter based on that. So we have this red line, or this group here. That's probably a subgroup of applicants that we don't want to give a loan, because they have a tendency to actually default, or at least that's what our model is telling us. At the same time, we have a bunch of groups down here that are much less likely to default according to the model. So this is a good way to actually just generate some information about where the model is good and where it's not, and also in your data, which kind of groups of applicants do I want to approve and which do I not. But for the time being, let's close it and just accept that this is an okay model for what we've invested in it so far. So the next step is pipeline comparison. So let's say we have multiple pipelines. Then I can go to pipeline comparison. I can actually, right now it's just the gradient boosting because that's the champion model. We can actually add more models here as challenges. For the time being, let's just go with this one. We click register model. And now it's registering into model manager. So in model manager, we can decide how we want to do version control. We can monitor the performance. We can score new observations. We can deploy it or publish it. We can publish it to a microanalytic service. So we get an endpoint API that we can use in different places to actually score new observation if we want to integrate it with a website, for example. This shouldn't take too long. So there we go. It's registered. Something I should also show you, because I promised this is also showing some of the integrations with open source. So there's a miscellaneous tab down here. So we see there's an open source code. So let's try and pull that out, put it into the imputation here. So now we have an open source code node. So in here, we can define if it's a Python code or an R code. So let's just try with some Python code, and let's let the system generate a data frame. In this case, it's going to be a pandas data frame. We're just going to open the editor. We see there's a training code editor and a scoring code. And I have some training code over here in my notes. So I'm just going to put that in here. So just create a few lines and insert it. So this is basically just a data set from a package sklearn. I think you're all familiar with that. And we're going to use the ensemble to create a decision tree. I actually think this is kind of like an old way of doing it. Nonetheless, that's kind of what we can do. We can click save. And obviously you can install all the packages you want on the system with Python. You could use XGBoost, for example, if you want. Just make sure that there's some kind of governance around it, so not everyone can do it. So we want to move this one. We want to move it to supervised learning. And we could basically run the whole flow again, and then we would have a Python model. I think I'd rather show you how you can do this with native Python code using a Jupyter Notebook and just connect to SAS instead. So let's skip that part for now. So the last thing is once you put your model into Model Manager, this is kind of the inside report. So let's say that you're a bank, if you're familiar with any companies that work in a highly governed industry, then you know there's going to be some kind of model risk management team, there's going to be model validation. You know, all of these things needs to be in place because if someone comes from audit, you kind of need to be able to show it. So this could be a good start for creating one of these model validation reports. But let's jump on to manage models. So again, we click on the burger menu and we go over here. It's just going to load a second. So we created our project before, data science conference demo 2. So let's click on that one. We see in here, there's going to be one model. That's the gradient boosting model, our champion model. If we click on that one, we can see there's a bunch of code that has been generated. So the first one is the score code. Then there's an A-store file, and then there's a bunch of JSON. So JSON is basically the way we communicate with SAS when we do fit statistics and, you know, like a lift, rock, and error on a curve, etc. So we can do the same thing from Python and just send it into Model Manager. There's a list of variables. This seems fine. That's properties. So we can see this is, I created it. I'm via demo 1. The data did it, where it's stored, and what version it is. So for example, if I want to retrain it, I could make this version 2.0. If I just want to make a slight adjustment, a minor adjustment, I could call it version 1.1. So I always know who is actually making the changes and where is it stored and when did it happen. It's a classification model, it's a gradient boosting, the target is bad, the event is 1. This variable, we're just going to change that to event probability instead. If you have ever used Enterprise Miner, you will know this is kind of the default. And I think that is it. So let's click save here. And then we go to the project. And we have the same here. We have the variables here. I'm just for the time being deleting these two because we're not going to use them. So let's click delete here. That's fine. And then we have event probability and EM probability. Let's delete that one as well. We don't need that. But we see that the 13 or actually the 12 values up here is our input variables. So bad is not going to be listed here, but EM event probability is basically our substitution of that. The next tab is the properties. So the model evaluation, we can see we need to set this one event probability. And I think that is it. So let's just click save here. So the first one we can do here is we can score a new observation. So if we click run new test, and let's call this SAS GB for gradient boosting. We select the model. There's only one, so that's pretty easy. And let's just score the same data set that we create the model on. So the HMEQ, we click on OK. And we save it to our CAS library, the one we created at the beginning. We click run. And then this will be running for, it shouldn't take too long. But basically, it's going to take that data set. It's going to score each individual row, so we can see what is the model output. So while we do that, so while that's spinning, the first thing we can do is we can add a model. I'm going to import it. And one of my colleagues is an R coder, and she created an R model for me. So I will select that one. So she created a zip file with all the information I need. So basic thing about it, I have the score code, I have the training code, I have all the JSON files with the fit statistics. So I'm just going to double click on that, and I'm going to import it as r_XGBoost, and then click import. So basically, you don't even need to create the model on the same server, and just basically export it and then import it over here later. So on the XGBoost, if we click on that, so again, we see there is some score code. If you are familiar with R, this is probably how R looks. We use the fast dummies and XGBoost libraries. We create a score function. We have the same, we have imputation, and then we have the prediction with the model itself. And again, we have fit statistics. So again, it's just a JSON file. So we can actually use this to compare models across languages, and we can do it quite easily, actually. I will just wait a second to do that after we have done our Python model. So let's go back to the project here. We go to the scoring, and we see that this is actually completed, and it's a green mark. It means it was successful. So we click on the results. And then we just put it over here. We see EM event probability. That's the probability of someone being a defaulter or someone not paying its loan. And that is a classification rate. We haven't set the cutoff between being a 0 or 1 for the classification yet. So I think the standard is just 50-50. We can obviously change that to maybe 20. So it's in line with our split in the actual initial data. But we see this one, for example, that was actually a bad defaulter. It has a 40% probability rate of defaulting, but it turned out that our model classified it as a 0. So this is like a misclassification. The same down here, someone who is not defaulting a bad, but actually our model says that, hey, this is a person that will default. So that's how it is when you work with analytics. So this is how we can score data. Obviously, we don't want to go in here and do that every time we have a new application or a new loan applicant. You can also see the code, what code was used to actually score these. This is just SAS code. If we do the same with the Python model or an R model, we will see that it's our Python being used. So let's just close this one. And I think, let me just take my notes here. So import the R model, we have done that. And we have scored a new data set. So we need to compare these two models. So we can click on both of them. We can compare them. So I mark them and click compare at the top. We can see the left one, that's our SAS model. The right one is our R model. So the score code type is R for the R model and DS2 for the SAS model. And we can see what is the fit. It seems like the R model is probably maybe a bit better than what we have at our gradient boosting model in SAS. But again, I think my colleagues spent quite a bit more time on creating that model than we have on our gradient boosting model. So yeah, we can also show the differences. What are we actually seeing here? I think it's pretty much the same. But yeah, that's the kind of gives you the option to compare across languages once you have imported SAS. So let's close those models. So now we have a SAS model and we have an R model. So now we kind of want a Python model as well. So I take my URL up here, copy it, open a new tab, paste it, and then I put in hub, I think. That's not correct. I've put in Jupyter then. Okay. Jupyter. and it will take me to my Jupyter Notebook or Jupyter Lab instance. So at the same time, we see there is a full Git connection. So I have my Git library is this one, open source integration SAS Viya. So this is my Git. Every time I make a change here, I can push it back. So this both works in my SAS installation, but also in my Python. So this is an independent installation. It's on the same Kubernetes cluster, but it's in its own pod. So it's not on the same pod as Viya. So basically, we need to use APIs to communicate with the SAS Viya installation. But I already opened a notebook over here. So the first thing we do is basically loading a few packages. So we use all the standard packages like pandas, numpy, system, plot some stuff, request to use the APIs. We're using sklearn to create a model. And we have some more general stuff here. And then the bottom packages here are the interesting one, I think, from a SAS perspective at least. So this is how the SWOT package is how you communicate with SWOT or with SAS and the CAS engine. So basically, we have our data stored in the CAS library. So because that's stored there, we kind of want to extract it to Python and create our models using sklearn. Once we've done that, we want to push it back to Model Manager. So I think step by step is we import the packages, we connect and download the CAS dataset. We do a bunch of data analysis and split data. We build pipelines and we train a model. Then we create all the JSON files, basically the same JSON files that we have in our SAS and our R model. So the raw curve, the error on the curve, the lift, all those things, we need to create them as well. We need to make a pickle file or basically serialize the model. Then we create the score code, and then we create a zip file with all the new files, and then we import that into the Model Manager. But instead of doing it in Model Manager, we just do it through API calls. So the first thing is that we run this bit here. Let's just try and run the code actually. So I put in my Viya demo 01. I click enter and I put in my password. So we see this is connected. There's one node and 8 total actions executed. So my host name, my username and password. I have a binary connection and I also have an HTTP. This is not HTTP, this is HTTPS method that I can use with the API. And I have my, I should have put that as DSC demo 2. Let's just do it again. So Viya demo 01 and then my password. So it's running. So the first thing I do is look into my my library, the CAS user library, and I see that there's the HMEQ dataset, the one we have used to create the SAS model and the R model. So we kind of locate that. Then we want to put it into a variable, so HMEQ. So now we have a SAS data frame. We can convert that to a SWOT data frame, SAS data frame. This is a subcategory of a pandas data frame. So we can use all the native Python code on this specific data frame. It will behave the exact same way. So if we use the shape, we can see we have 13 observations and we have roughly 6,000 observations. So it seems to be loaded correct. Start doing just the general data exploration. Basically what we did before in our visual analytics, we can just do it here with code. We create the plots. We can see the distributions. We can see, I think I have something with missing variables. So here's how many percentage is missing. We can see that the DROC and the debt to income is kind of the worst ones. We can create plots for our categorical variables. So again, we can see there's some missing in reason and there's some missing in job. But generally speaking, it's when you want to take one of these loans, at least in this data set, it's because you want to reconstruct your debt. So maybe you want to take your car loan and put it into your house loan instead because you have a lower interest, or you want to do some kind of home improvement. Maybe you want a new roof or something. There are some different jobs. Most folks work in the category called other, and some of them are not even put in the application. So we just use the standard function of of splitting our data. So first we create the numerical and then the categorical, and then we split our data. We use 70-30, so the same we did with the SAS model. We're not using the same seed, but I think that doesn't really matter in this case. We use pipelines in sklearn. So we build first the categorical features. We want to use imputing, constant, and missing, and we want to put in a median for the numerical, and then we're going to build it into a preprocessor, just a whole preprocess. We want to train some models. In this case, I have a logistic regression, I have a decision tree, and I have a random forest. So let's just build them. It's going to take just a few seconds, I think. Yeah, that was the first one, the second one, and the third one. And then we just want to check performance just to ensure that it's not some rubbish we've made. So we see here that the random forest seems to be the best one. It has a misclassification rate of 0.09. So that's basically, now we created the model, and we did it basically using native Python code. So no SAS or anything here. We could have done this using SAS actions instead. So if you code SAS and you use the cache, it comes with action sets. You can actually call these actions from Python if you want. I'm just skipping this bit, but basically you can use the neural net action set, and you want to do basically just train a neural network. You can put in all the information for the action. You can score it, and then you have a neural network. So basically, we could have done the same thing we just did here, just with cache actions. But next step is we kind of want to register the model into a model manager, and I think we're just going to take all 3 models, and then we're going to compare them in a model manager instead of actually doing it in here. So the first thing is we're going to create 3 new folders. And if we go to Python model over here, these are basically the 3 folders. And I already created them, so I'm not going to overwrite them. But a decision tree classifier, logistic regression, and random forest. Then the next, I've kind of created a function. There's this PCMM package in SAS. That was one of the first packages we loaded in. And that can be used to create the JSON files and the score code and everything we need to actually register the model. So the first one is we actually create the JSON file. So we make a file with the input variables. We make a file with the output variables, and we make one with the general model properties, or the metadata, so to say. And then we score some data set, and then we create the fit statistics and the rock and the lift stat. Then we pickle the file, or serialize the file, and then there's a function to write the score code. And then we can basically just run this for all 3 models. So let's try and run this block here and see what happens. Wait, that was not it. I need to do it like this. Wait, like this. So we are running it. We can see that the JSON files are created, the DM class fit stats, all the files are created. So if we go to, for example, the random forest here, we can see that all the JSON files are created, the pickle file, and the random forest score has been created. Well, that's the scoring code, the Python code. We can actually just open that and see that this is what the system just generated for us, the SAS package. So when we want to use the score function, for example, in Model Manager, this is what we will be scoring new data with. So we can put this in Model Manager. For that, we will use a session with the connection we did at the top, the HTTP connection, and then we will create a zip folder, or basically just zip it. I have one already, but I'm going to do it again. And then we're going to use this API call here to put it in Model Manager in that project we just created. So we click Shift Enter, and this is going to take a few seconds, I think. Yeah, so it's done running. So if we go back to Model Manager here, so this is we still have our SAS model and our R model. So if we just update this project here, click on the update button at the top, we will see that now we actually have a Python model as well. Actually, we have 3 Python models. So again, we can take the decision tree, or actually the random forest was the best one, this one, and the SAS model, and we can click on compare. So now we can compare models across all 3 languages, basically just by clicking the button. That's I think that's quite strong. I've often been working with data scientists that are only coding in Python, or only coding in SAS, or only coding in another language, and just making that collaboration, or at least we can work across these teams, seems to be quite valuable. So yeah, that's the models. And again, we can show differences. I think that's basically just the same thing. So we click close here. We can do scoring. So let's try and do that with the Python model. So Py, and let's take the random forest. We can choose the model. The random forest it's this one, the Python one. And we want to use the HMEQ dataset. We want to do it with the cache user. Just store the results here. We click run. And then this is probably going to take a second. I'm going to show you what's actually in the model folder as well, for the Python model, just like we did for the R model. So maybe do that while we are waiting on that one. So we can just click off that one, getting out to the home page with all our models. You see, I've been doing this using the server for a while now, so there's 21 models. Let's just sort on modified. So we have random forest. It has a tag of Python, so we know it's a Python model. We can just click on the model, and we can see all the model information. So this is the score code we just generated. There is some example test by random forest. Basically, there's the input, the output, and there's all the fit statistics that we need. There's a wrapper. So basically, when we execute the Python, we do it by wrapping it in SAS code. So that's what we're doing here. So that's basically what we are getting in Model Manager. And we can still see that the variables are EM classification and event probability. We can see the properties. It's a random forest. It's created by Python. It's a classification model. It's Python 3, version 3.9.1. That's very important. If you want to import a model, you kind of make sure it's the same version that's used by SAS. So there's actually a Python installation with SAS, and we're using a different installation outside SAS to create the model. And we have the version control over here. So right now we haven't done anything. And we could actually change something and just click save, but let's do that for something else instead. So that was the model. Let's go back to the project here and see if it's done running. So yeah, it has generated the results, and it's a green one. It's done. So let's just open up the data set here. So again, we can see there's the probability and the classification. So this is actually a fairly good model. It seems to be correct. Oh, here's a misclassification. Yeah, that seems quite fair. So let's close that one. And let's go to the models. Let's assume that this random forest is actually our best model now. So let's set it as a champion. It says that our gradient boosting model will be replaced by the random forest model. I'm actually sure I want to do this. For the time being, I am, because right now we don't really have a governance model, but usually you would probably have some kind of 4 eyes principle. So if someone is changing the champion model, you probably want someone else to confirm that this is indeed what we want to do. So now this is our best model. So let's actually try and deploy this model. Let's see, just a second. That seems to be on track. So we have the random forest. We also have the SAS model. You know what? Let's just deploy both of them. So we click publish. And in here we have a publish destination. We can use CAS. Then it's just going to stay in SAS with the cloud analytics service. But basically want to use a micro analytics service. That means we get an endpoint or an API that we can call from, for example, Python to use the model to score new observations. That's going to be pretty neat if we are going to embed it in a website, for example. Do we want to assign tags? That doesn't really matter. We kind of want to override. So let's say this is the SAS GB, and let's call it DSC Demo 2. This is the Python model. Let's call it Python Random Forest DSC Demo 2. We can click Publish. So right now we are creating a new destination where we are deploying these models. And this shouldn't take too long either. That was the Python model that's deployed. We can see where it's deployed at. The gradient boosting is taking a little bit longer for some reason. All right, there we go. So both these models have now been deployed to a micro analytics service. So we close this one. We can go to the deployment tab over at the left side, and we see all the models that we have deployed. Can we make this bigger? No, we cannot. So yeah, all the models we have, versions and all that stuff as well. So again, if we look at the two models we just deployed, is SAS GB DSC Demo 2 and the Python RF DSC Demo 2 as well. The Python model is the best one. Let's just copy this one, and then we go back to Jupyter Notebook, because now we kind of want to use the API to actually talk to Model Manager. So in here, the first one we need to do is kind of verify that we have the authority to actually talk with the API. So we generate the token here. Then we want to talk to a specific model. So that model is going to be the PyRF DSC Demo 2. Call not executed to pending input. We just click enter. Sorry. Then we need to kind of say what is the URL for the model. So basically, it's the microanalytics store modules plus the model name plus steps. Then we get a list of all the things we can do, and we kind of get a get response. So let's do that. And obviously, we get an error here because we're doing HTTP calls instead of HTTPS. So I haven't uploaded the certificate to the server and my computer. But obviously, that's something you want to do if you are having a production setup. So here we can see there is all kinds of things we can do. But what we're interested in is the bottom one. That's the score functionality, and we can see what kind of input the model expects. So again, we need to send the input as a JSON format, and we want to do it to this specific URL, and then we should get a response back. So again, we kind of create the data in a JSON format, and this is quite tedious, but that's just how it is. We can send a request, so we generate the header, and we give it the token. We have the URL, and we make a post. So we can see here that if we send this data, so it has a value of 12, or the CLH is 12, the CLNO is 0, debt to income is 25, delinquent credit lines is 1, etc. We can see that this has a 60% probability of defaulting, and that is converted into a classification of 1. That means this is someone we don't want to give a loan. So again, we could make a form on a website where you just click in these variables or this information probably as a customer, or you can also do it for your credit department, and then they get a response back. So we could also do the same thing just using the Python model. I just want to show that we're going to get the same result. Fingers crossed. So we are creating the score data, data frame, and then we should look like this. And then we can print the probability. So we're using the random forest predict prober, and then we run it like this. So we see it's 0.59. It's the same value we had up here, 0.59, and it's a classification of 1. It's a classification of 1. So basically, our SAS instance is doing pretty much the same thing as we're doing here. We're just doing it with an API endpoint. So something that's quite interesting is that one of my colleagues has built what we call a mass client. So we can see all the models we have deployed here. Probably want to update it here. So these are all the models that are currently on this mass installation, have been published. So we can see this one is Pi Random Forest DSC Demo 2. That's the one we just put in here. We can click on that one. We can see there's a score functionality. If there were more functionality, it could be retraining or monitoring or whatever. Then we could also use those APIs. But for this instance, we just use the score, and we could put in the same information that we just put in. You know what? I'm just going to put in whatever. It doesn't really matter. Income 0, DROC 0, job. Let's put other. Loan. Let's say 10,000. How much is left? Let's say it's 25,000. And non-reason. Let's say home improvement, and the value of the house. Let's say it's 1 million. How long have you been in your current job? You have been there for 5 years. Then we can execute the step. And we can see that this is the response based on this applicant. So result code is 0. So the API call was good. This is a classification of 1 because you have a 48% probability of defaulting according to this model. So this is basically our application. So just imagine this being embedded in a website or an app or wherever you kind of want to do it, and then just communicate with the CAS instance or the mass through the API call. So that was basically the first bit. So now we basically created the model. We created the how we can use the model, the API, and all that. Now we also want to govern this model. So how are we going to do that? Let's go back here. So in the project here, we can see in the history, so all the things we've done today. So the first one down here was the first the version was created. We put in the first model. That was the SAS model, the gradient boosting model. Then we put in an R model. We put in a decision tree, a random forest, and logic regression from Python. Then we changed the champion, and we just published 2 models. We can see the information about where we published the 2. What we probably want to do is add a workflow, and a workflow is like a in this instance, if you have your governance model, so to say, in a structured Word document or something, you kind of want to simulate the same thing happening in your system here. So if we go to the burger menu again, we can go down to manage workflows, and I created a simulation or a demo for how this could look. The best model governance ever. So we click on that one, and in here we have some steps we can apply to a project. So for example, if we want to assign a champion or a challenger, we want to keep the scoring, we want to calculate model performance. Each time we do this, we can see there's a little man here. That means a notification is being sent to someone that we have assigned to this role. It could be a department, it could be a person. And then they have to go in and use basically what we call a 4i principle. So verify that this is indeed what we want to do. We want to keep scoring, we want to keep the model performance. And then every month or every week or every day, however often we create a model performance, we want someone to actually assess that report. Is the model still performing as expected? For example, if you have let's say a misclassification rate of 0.5 and suddenly it's 0. Basically 20% misclassification rate, is the model still good enough for using? And then there's some options here. So the first option is that we can just keep scoring, keep using it. It's fine, or we can redevelop it. That's also fine, or we can simply retrain it. And I'm going to show you how we can retrain it directly in Model Manager because we provided the score code and the training code. We can also just retire the project, basically saying that, hey, we no longer need this model. For example, if you have a model for, what could it be, consumers for loans, but suddenly your bank don't want to do consumer loans any longer, then obviously you don't need that part of the or that project any longer, so you can just retire it. It's probably a bad example. So yeah, basically this can be applied to our project. So if you go back, and again, this is fully customizable, so you can basically just drag and drop, put in whatever task you want, and then put in filters and API calls and everything to basically control this. So basically, an email could be sent out, a notification in Teams, or anything you kind of like. So we go back to manage models. We go to the workflows here. And for some reason, I cannot select that. All right, we're going to take the other one. It doesn't really matter too much. So I have to select the owners. If there's multiple owners for multiple different processes, I will have to add them. So in this case, I'm a Viya demo 1. You can add either a user group or a specific user. So in this case, I'm just adding a user. Click start. This is a really bad example when it's not actually doing what I wanted to do. But what you should be getting is a task down here. Okay, maybe it is. So basically, it's the settings, the KPI settings are incorrect. So we'll tell you to actually do something. This task does not have any prompts. Because it doesn't have that is because it hasn't been set. But what it wants us to do is create a performance report. And that's kind of the last step I want to show you of how we would do or handle model ops. So we can create a new definition. Let's call it data science demo 2 performance. Tables, we will probably use a library instead. We will be using the cache user library, the one we've been using all the way. And then we can say that every time a data set comes in, HMEQ perf underscore 1 underscore 2 underscore 3 or whatever, we want this performance report to be generated. So let's say you want to evaluate your model on a monthly basis. You take in all your loan applicants with the target variable, and then you put it in here, and then you can see how good the model is performing. And you will probably see some shifts in variables, in distributions. You will see some shifts in performance of the model. So that's something we definitely want to add here. So the models we kind of want to monitor. Let's for the time being say the champion and the challenger. We have the champion is the random forest, that's the Python model, and the challenger is just the gradient boosting model. The input variable, we are going to select all of these 13 here. The output variables is going to be the event probability. We probably need to add one more. We can do that just in a second. We'll probably get an error, but let's click save here. Okay, we did. But something I should have done is actually adding in the event classification role here, but for some reason it works anyways. So let's try and click run, just run now. And normally it would just run in whenever a new data set comes in. And then that whole flow we showed you, this whole flow here would come in. So the data set comes in, the SS model report is created, and then a user or a group of users will have to determine what happens to the model. This is just a very simple governance flow. You can do this also when you put something in production. And for the first time, you see has the model validation been conducted? Do we have all the documentation in place? Who is the model owner? You know, all these things we can set up in a flow like this, so it's standardized across the business. So let's go back to manage model and see if that performance report is created. This could take quite a while because a lot of data sets and a lot of graphs are being created. So maybe we can just close this one, and then I have one created. I think it's this one. Hope it works. We have a performance report. So let's see if it's loading. So we can see there's 23,840 observations scored. That's because we have Q1, Q2, Q3, and Q4. We have 4 data sets with 6,000 observations in each. We can see what is the forest. So I think in this case, the forest model is a SAS model. So we can see the variable distribution. How does it look across time? So Q1, Q2, Q3, Q4, let's say 2020. So the percentage is actually shifting left here. So there's some kind of behavior change going on. And same if you take value. We see it's lower and lower amount of value that are being requested in the loans. So for example, in the market we're seeing right now, if you have an interest spike, you will probably also see some differences here. We can see on specific variables, we can see the distributions. And we can see it specifically for whatever quarter we want, for what data set. There's deviation indexes. So a high deviation index is a bad sign. It's probably time to retrain the model. The PSI features, it actually tells you here that if it's higher than 20, these variables are kind of shifted a lot. And we see that some of them are perfectly green in Q1. So the first 3 months we're using the model, it all seems to be good. Then in month 4 to 6, it seems to become quite an issue. 1 yellow and 3 red. And then in Q3 and 4, we probably should have retrained the model by now. So already probably considering it in Q2. We have the output variable, how that deviates across time. At the left, we can see that the performance is decreasing quite significantly. Basically, we will be scoring less and less correct. The same with the rock curve. It's worse and worse performance. The Gini. And basically, we can see this for all our models. The interesting part is if you have like a challenger model, you could see how would that have performed in the same time. So you could do some kind of A/B test if you want. Yes, all right. And then we can go to the models. I think the last step I want to show you is that you can actually retrain a model. So in this case, let's just take this forest model here, and we click on this one here, and click retrain. And we want to retrain it. We just want to retrain now. Basically create the same model, but do it on a different data set. So we know that the Q4 data set is the newest one. So we click on Q4. It has the same information as the HMEQ dataset. It's just the newest one. We click OK. We click Send. And then this could maybe take a while. Depends. But what we should be seeing is in our model over here, when we have, actually, let's go back to project. When we click on this one, we should see that should be coming a version 2.0. So this is actually already happening. So we could actually take that, create a new version again if we want, and then publish it again. And again, we want to put this, we want to use the tasks functionality here. So this should happen, again, someone should be notified. Can you actually deploy this? Has it been created? Is the new documentation updated? All these things, are they in place? So I think that's kind of how I would expedite the time from data extraction to data deployment using SAS Viya. So let's see. I think I had one or two slides more, perhaps. So just to summarize that, basically with SAS Viya, we are fostering collaboration, governance, and ease of access. So you don't need to be a SAS coder to use the environment. You can use drag and drop functionality. That's probably the easiest. And you can also use all the API endpoints. I think I showed you just a few of them today, how you can extract data to, for example, Python, or how you can use the API to score new observations. But again, you can create whole new projects, and you can do it in an automated way if you want. We have integrated with GitLab and just general Git functionality. So you can create CI/CD pipelines. You can automate the whole process if you want to. Seeing as you have an environment maybe already in Asia, maybe you want to use some of the Asia functionality to actually do that. We can do the full lifecycle. I haven't showed the data management part of it today, but that is something we are perfectly capable as well. I think most people use SAS for data management today, and then build skills on top of that. It's an open platform. We can use R and Python. You can also use Lua and also all the REST APIs. And again, you can get started using the pay-as-you-go application on Asia Marketplace. It's a fully administrated application, so you don't actually need to do anything. You can just log in, and then you are pretty much good to go. And I think that concludes my demonstration for today. I know it was probably quite a lot of functionality in a very short amount of time. So if there are any questions, I'm happy to answer them. I take that as a no. If you have any questions offline, you are very welcome to shoot me an email. It's mike.johansson@sas.com.
Thank you, Mike, for an amazing presentation and tutorial.
Yeah, thank you for giving me the opportunity.
It was really interesting. I really enjoyed it. And for all the viewers, all the materials will be available to you, as well as the video of the presentation.
Thank you, everyone.
Thank you. I hope you had fun presenting.